Welcome back, everyone, to another deep dive. You know how we do it here? We take something that might seem a little complicated at first, and then we dive deep.
That's right.
And today, we are diving deep into the world of plants, specifically how they manage their water, especially when things get a little dry.
Yeah.
So, have you ever noticed a plant wilting, even when, like, the soil feels damp?
Oh, yeah, for sure.
If there's a reason for that.
Absolutely.
And it's pretty fascinating.
Yeah.
It all comes down to this thing called osmotic pressure. Have you heard of that?
Yeah, osmotic pressure. Basically, water doesn't just flow freely into plant roots.
Right.
There are these forces at play, kind of battling it out.
Right.
And osmotic pressure, well, that's one of the key players in that whole process.
I've got to admit, osmotic pressure, I mean, that always sounded kind of intimidating to me.
Yeah.
Can you break that down a little bit? Like, what's really going on there?
Sure. Imagine you have a glass of water, right? And you divide it with this special membrane, something called a semi-permeable membrane.
Okay.
Now, this membrane, it lets some molecules through, but not others. That's what makes it, semi-permeable.
That's right.
So then you add some salt to one side of this glass.
Okay.
The water molecules, they're going to start moving and they actually move towards the saltier side. They're trying to balance things out.
Oh, interesting.
That movement, that's essentially like osmotic pressure in action. It's all about trying to reach equilibrium.
Okay, I see. So how does this work in the soil, though?
Pretty much the same way, actually.
Oh.
If the soil is really salty or if it's, super dry, you get this high osmotic pressure situation. And what happens?
What happens?
Well, it makes it harder for water to move into the plant's roots. Those water molecules, they're being pulled in the opposite direction, you see. It's almost as if the plant is trying to, suck the water up through a straw. But it's really, really thick. It's like trying to drink a milkshake through a tiny straw, you know?
That's a great analogy.
It just makes it that much harder.
Wow. And that's only one side of what's happening, right?
Right.
Because plants are also losing water through transpiration, that like the sweating process.
Absolutely. And the rate of that transpiration, it's affected big time by how dry the air is.
Okay.
There's this thing called vapor pressure deficit, or we call it VPD for short.
Yeah.
And basically, the drier the air is, the higher that VPD is going to be. And the faster that plant is going to lose water, just like we sweat more on a hot, dry day.
So if we think about both of these things together, you've got that osmotic pressure and this VPD.
Right.
This is where the double stress comes in, right?
Yeah, you hit the nail on the head there.
Okay.
When the soil is dry or salty, right, you got that high osmotic pressure. And at the same time, the air is dry, which means high VPD. Well, it's like a 1-2 punch for that plant.
Oh.
It's losing water super fast through its leaves, but it can't replenish it from the soil fast enough because of that high osmotic pressure, right?
Ugh.
And that imbalance. That's what causes all sorts of problems. You get wilting, the plant's growth is stunted, and, sometimes it even messes with how it takes up its nutrients.
Hold on, nutrients too? I thought it was just a water thing.
Well, remember, plants, they need to absorb dissolved nutrients from the soil to grow, right? But if that osmotic pressure is out of whack, the whole movement of those nutrients is disrupted. It's like trying to push a shopping cart uphill. Everything's working against you.
So the main takeaway here, if I'm hearing you right, is it's all about balance.
Exactly. Plants need that sweet spot,
Right.
where that osmotic pressure in the soil is low enough so they can easily take up water and absorb their nutrients. But at the same time, the air can't be too dry either. That VPD has to be manageable so they're not, constantly losing water like crazy. It's got to be just right, like Goldilocks.
This is so cool. It really makes you think differently about what's going on, beneath the surface.
It really does. I mean, you think about your own garden
Yeah.
and all the things that are happening that you can't even see. It's amazing how plants have figured out ways to deal with all this.
Well, I know.
Yeah.
What are some of the ways that they cope with this?
Well, for example, some plants can actually accumulate sugars in their roots. And that creates a kind of counter pressure, helping them to draw in water even when the soil is dry. It's pretty remarkable, isn't it?
That is incredible. Thinking about all of this, it just makes you realize that even something as simple as watering a plant, it can be a lot more complicated than you might think at first.
It really is. It's not just about, dumping water on the soil. It's about
Yeah.
understanding the forces at play and how they impact the plant's ability to thrive.
So next time you're out in your garden and you see a plant that's looking a little droopy, think back to this deep dive. Could it be a high osmotic pressure situation in the soil?
Maybe.
Or, maybe the air is too dry. Maybe it's both.
Could be both.
And here's a question for everyone listening.
Okay.
As our climate changes and we're facing more droughts and problems with soil salinity, could understanding all of this, the osmotic pressure, the transpiration, could that be a key to growing more resilient food crops in the future?
That is the question, isn't it? And it's something to really think about.
It is.
Yeah.
It is. Food for thought, literally.
Literally.
Thanks for joining us for another deep dive. We'll see you next time.
See you next time.